Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 10.5, Problem 3. This is Section 10.5, problem number 3. It says, evaluate each logarithm without using a calculator. So, and then there are 6 different logs that you are asked to do without a calculator. So the first one is log base 2 of 64. So what they're really looking for is what's the exponent that you need on the 2 to get to 64. Because again, in its log form, this is b n e. There's no exponent written, but that's what we're looking for. The b is for base, the n is for the number, the e is for the exponent. The base is 2, the number is 64. The exponent is unknown. So 2 to some exponent equals 64. Well, it would be 6. So we have 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is 32, times 1 more 2 is 64. So 1, 2, 3, 4, 5, 6th power. So log base 2 of 64 equals 4. You're looking for the exponent on the 2 that would raise it to be 64. So now part B also has a 64 and it says log base 8 of 64. So you want to do that without a calculator. So again, the log base 8 64 in its log form, you have b n e, Benny, b for base, n for number, and e for exponent. So the base is 8. The exponent is unknown, that's what we'll try and solve for, equals, and the number is 64. So 8 raised to some exponent equals 64. Well, that exponent must be 2. 8 to the second power equals 64. So log base 8 of 64 equals 2. That's the answer for part B. Part C also has a 64 in it. It says solve log base 4 of 64 without using a calculator. So again, in its log form, this is b n e for base, number, exponent. The b for base is 4, the n for number is 64, and the e for exponent is unknown. So the base of 4 raised to some unknown exponent is 64. Well, that should be 3, right? Because if you do 4 times 4 is 16 times 4 again is 64. So log base 4 of 64 equals 3, and we can do that without a calculator. And part D, same type of problem. It says solve log base 9 of 81 without using a calculator. So in its log form, again, I write Benny, b-n-e for base, number, exponent. The base is 9, the number is 81, and the exponent is unknown. So in its exponential form, we start with the base is 9, right? And then we say the exponent, so I'll just leave an e for exponent, equals, and now the number is 81. Well, 9 to some exponent is 81. That exponent must be 2. 9 to the second power is 81. And part E says ln(e). And again, ln is for natural log. Now, this one seems tougher. It's actually not tough at all. ln is an abbreviation for log base e. So what we're asking to do is solve log base e of e. So again, I'm going to write Benny, b-n-e, and I'm going to put that back into its exponential form. So the b-n-e is for base, number, exponent. So the base is e, and the exponent is unknown, so e to some unknown exponent equals the number, which is still e. And again, that e is just that special number from natural science, 2.718, and it goes on and on and on. So e raised to some exponent just stays e. Well, the exponent must be 1. E to the first power would just be e. And finally, part F, log base 7 of 1. What's that without using a calculator? Well, again, in its log form, it's Benny, b-n-e for base, number, exponent. The base is 7. The exponent is unknown, so I'll just leave an e for exponent, equals, and then the number is 1. So 7 raised to some sort of an exponent equals 1. This one you might have to think about a little bit, but once you see it, you'll realize what it has to be. 7 to the 0 power equals 1. Remember, anything to the 0 power is 1. So log base 7 of 1 equals 0.